Okay, so what do we do first? We analyze the graph. I know that it looks overwhelming because there are so many points, but in the end, the same idea. Okay? You're gonna get average velocity from 1, 2, from 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 9, 9, 10, 10, 11, 11, 12, 12, 13. You will expect these average velocities to be all of them positive, and you will expect only these two to be negative. Is there a point where the average velocity is going to be 0 here?
9?
9. Here in this point, what happens is a change in direction. There, in that point, you're changing direction. Because you were initially going in a positive direction, and in that point, 9, a change of direction occurred. And then again, at the point 11, another change of direction occurred. But no, in that moment, just in the 9, just in this point, exactly like this, then yes, only in that specific point, you can say that the velocity might be 0, but not in a range. Okay, not in a range.
Me?
Uh-huh. Yes. Okay. Okay, let's focus on the question. The first question says, which verb has the greater average velocity over the entire period? Okay? Which verb has the greater average velocity over the entire period? So what do you have to do in the first question? You're going to analyze just for verb A, for example, you're going to analyze the initial point and the final point. So that's what you're going to analyze, okay, over the entire period. What's the average velocity? So you're going to analyze initial and very final position. Astrid, what's so funny about the verb A? In the so you will do okay, for question 1, okay, you will compare the initial position and the final position of each verb. Initial and final. So you will assume for that thing that, wait, I'm sorry, wait, that is very difficult to work over an image. Okay, so this is what you're going to do. This is what you're going to analyze: the initial and the final point of each verb. For the first question, okay? No need to do the line. The line is only from a reference that I'm doing for you to see. I don't know what the answer is. I mean, the exact answer is, but I see the slope, okay? I notice the two slopes. And I see that this one over here is more tilted for that sand, okay? It's like more vertical. I don't know what the answer exact is. I'm not going to do it for you, but I see that it's more vertical. When you see a slope that is more vertical, you say that the average velocity is going to be greater because of the slope, okay? In here, because of how the slope looks like. Another way to see it is here, the final position is approximately at 1,500 meters, and here the final position at 2,800 meters. So, what slope took the bird to the highest position? Well, the second slope. So you can say the second bear B, has the greater average velocity. Which one is the average velocity? I don't know it. Okay, you're gonna get it. Now, in the second question, it says, which bear has greater velocity at time equals 8 minutes? Okay, so you're gonna see the time, and you're going to look for that where the time is approximately 8 minutes. Okay, so more or less is gonna be here. More or less is going to be here. For the bear A, more or less here is the time 8. So you're going to get the average velocity. How? Well, applying the formula. Okay, for question 2, the formula for average velocity is final minus initial divided by final minus initial. Okay? But because I'm talking about just a specific point, the point where the time is 8, I'm just going to use the time and position at 8. Okay? So I say position. In what position? Well, I have 0, 100, 200, 300, 400. Here is 500. Okay? So in what position? 400. In what time? 8 minutes. How much is this? 50, right? Is that 50?
Yes.
Okay. So I get the first average velocity. Now I do the same for the second bear. Okay. More or less my time 8 is in here. And I see the position. Okay. The position at 8 minutes over the time at 8 minutes. Okay. Position 200 meters. Time 8 minutes. Average velocity 25 meters per minute. So, which bear has greater average velocity? Exactly where the time is 8?
Bear A?
Bear A. Okay? So you answer the second question. You compare the two answers. Okay? The greatest is 50. So bear A has greater velocity where the time is 8 minutes.
Miss,
Uh-huh.
and that same formula is that we will use to calculate the average velocity of the first question, right?
Exactly. The same formula for the first question. Okay? The same formula for the first question, but you're going to use the 2 points. The final point that is 13 and the initial point that is 1. The final point that in here, I don't know which number is going to be, and the initial point that is here. Okay? So every line represents 100 meters. Okay? In the position part. And in the minute, it's going 5 by 5 minutes. Okay? Let's focus on the question number 3. Is the velocity of bear A always positive? Is the velocity of bear A always positive?
No.
No, we already answered this in the first analysis because we saw that in these two parts, I'm going to have a negative velocity. Okay, so you can answer your question as no. Then the last question says, is the velocity of verb B ever negative?
Yes.
In what part is verb B negative? Let's analyze the verb B. I'm going to erase this. Okay. Now let's analyze the graph in verb B. How is this slope? Positive or negative?
Positive.
Mhm. This one
Positive.
is, it looks like it's straight, but it's not. It's a little bit above, so it is positive. How is the slope? Positive or negative?
Positive.
In here,
Positive.
in here,
Positive. All of them are
Positive.
positive.
positive. It looks like a zero, but it's actually a little bit above. Okay. This one is positive or negative?
Positive.
This one?
Positive.
So you can see that all of them are positive. Now, can we answer the question? Is the average velocity of Barbie ever negative? No,
No, it's not.
it's not. Okay? His velocity is always positive. So I know that the exercise at first sight it looks like overwhelming because you see two graphs, too many points, and too many questions. Okay, too many questions. But once you analyze the graph, you see that is exactly the topic that I told you the other day. Okay, nothing new. What is new is that you guys are starting to work with the specific word problems for average velocity. Yeah, that could be new. So I hope that with this class discussion, now you know a little bit more on how to answer the questions in your homework. Okay? So I sent you one exercise, like exactly like the one we did, and this one that is a little bit different, but in the end, it's the same topic, the same idea. I didn't actually do anything different. So how do you think the exam is going to be? The quiz is going to be?
It should be pretty simple and easy.
Actually, pretty simple. Pretty much simple. So if you want, I can give you a review. If you don't want, let me know, okay? But if you want, I can give you a review of average velocity.
Yeah.
Okay, let me show you something. This is, okay. Wait, something, I don't know, something is, yeah, now I have it. Let me project the whiteboard again, now with an exercise as a review. Okay, so I give you a graph, okay? In this graph, you have position in the vertical axis and time in the horizontal axis, okay? And here there are the questions. Okay, it says identify the intervals at which the average velocity is 0. In what intervals I have average velocity 0?
B to C and E to F.
Exactly, BC and EF. So take a look. This is an exercise very similar to the one of the bears. I'm asking you questions and you get it. Okay, so take a look. The intervals at which the average velocity is 0. So we say BC and EF. How do I know that? By just taking a look. By just taking a look to the wait. Now it's better. Okay, now it's better. Yes. Is that I was not feeling comfortable working like that. Oh, I see. So A to B, positive or negative?
Positive.
Positive. BC,
0.
0.
0.
Ajá. CD,
Positive.
ajá. DE,
Negative.
negative. And EF, with the
0.
0.
and FG,
Negative.
negative. So, just from the pre-analysis of the graph, we can answer the first question. Okay. Now let's focus on the second question. Identify the intervals at which the average velocity is positive. Okay, we already did. The average velocity positive at
AB
A,
and CD.
AB, CD, and that's it, right? Nothing more. No more positive ones. Then it says, identify the intervals at which the average velocity is negative. Negative.
DE
Mhm.
and FG.
Very good. Then it says, calculate the average velocity in the intervals AB, and here, of course, we have to do a procedure. So how do we get the average velocity in AB? What is your final and what is your initial?
A. The initial is A and the final is B.
Okay, so the formula is going to be The formula is going to be average velocity AB is going to be equal to what? What is the final?
Final, B
Minus initial,
minus initial,
that is A, over time final, that is B, minus time initial, that in this case is A. We substitute by the givens. XB, position at B is
40 meters.
Position at A is
0,
Time at B is
2,
2 seconds.
and of A is gonna be 0, 2.
So 40 minus A minus 0 is 40 meters. 2 minus 0 is 2 seconds. So this is equal to 20 meters per second.
Miss, this example is like the one of the homework, right?
Yes. So if I ask you, identify the average velocity between the point, because I can tell you that, or calculate the average velocity between B and F, what is the average velocity?
Is 0.
Is 0, exactly. Okay? Why? Because if you trace a line between those 2 points, you're going to see that the slope is 0. Therefore, the average velocity is going to be 0. So, how is positive or negative? How is the average velocity going to be between the point B and G?
Negative.
Yes, it's going to be negative because if you join the points, the 2 points, B and G, it's going to give you a negative slope. If you join the points AC,
AC is gonna be positive.
Positive.
it's going to be positive. See, that's the kind of analysis that I want you to do with a graph. Okay? Now, what else can we do with average velocity? We can do word problems, like the one of the bear, but without a graph. Okay? Not necessarily always we're going to have a graph. So let me show you something. Not all the time, I'm going to give you a graph. Now for Monday, that is the quiz, we can do a quiz just about a graph, okay? Take a look at this problem. It says, during a race on level ground, Andrea runs with an average velocity of 6.02 meters over second east. What is Andrea's displacement after 137 seconds? In this kind of exercises, I always suggest that you take a look to the units. Sorry, that's the iPad. Pressing the wrong key. Okay. Now take a look. Always check that the units that I give you are already converted, which means velocity needs to be in meters per second. Is our velocity in meters per second? Is our velocity in meters per second?
Yes.
Always check that the time is in seconds. Is the time in seconds?
Yes.
Thank you. Okay, so always try to see that, okay? Always try to check that displacement is given to you in meters, that velocity in meters per second, and the time in seconds. Those are the units that you need to have, okay? Displacement in meters, velocity in meters per second, and the time in seconds. I don't know if you can hear me well. I can see that it's taking some time to appear. Whatever I do in the iPad is taking some time to appear there in the whiteboard. So I guess my connection is not very stable today. So what do we need for this kind of problems? First, we identify the givens, okay? The problem gives us information that is going to be always in a number, okay? So it says that Andrea runs with an average velocity. That's a given, okay? So you say average velocity, 6.02 meters per second. And you specify the direction. East is positive or negative?
Positive.
Exactly. Remember this. East is in the right side and is positive. West is in the left side and is negative. Okay? Remember that. So because it's going to the east, this velocity will consider to be positive. They are giving me a time, okay? Because the time is measured in seconds. And they're asking me to find displacement. It says, what is Andrea's displacement? So I need to find displacement. Displacement is denoted by delta x. I don't know it, okay? So, what do I do? I'm going to copy the formula for average velocity, okay? And from here, I should be able to isolate for the unknown. I need to find displacement, denoted by delta x. So, you need to isolate, okay? So what happens when you need to isolate? This number or this value that is dividing is going to go to the other side by making a multiplication. So you say average velocity times time is going to give you delta x. That equation is the one that you will use for displacement in case that you need to find displacement. You can leave it like that or you can write it like this. The displacement is equal to average velocity times the time. You substitute by your givens, okay? 6.02 meters per second multiplying the time, that is 137 seconds. You get rid with seconds and seconds. And how much is this? You're going to multiply because the two numbers are beside. You're going to multiply. How much is this?
824.74?
800?
24.74. If I'm not mistaken.
I couldn't hear you well, but I heard 824.
Point
Point seven.
74.